Hi everyone, before we start, this glove is for my running pad. I'm not being silly, okay? And before we jump into the examples, I just want to remind you of a few things. First one, 2 units to measure heat energy, the joule and the calorie. The standard unit, the SI unit, is the joule, okay? And calorie, it is related to nutrition and food. But if we write calorie with the capital or uppercase C, which is the one we use for food, we are really saying a kilocalorie or 1,000 calories. For instance, if I were to say this McChicken has 400 calories, capital C, I am really saying this McChicken has 400,000 calories, lowercase c. Okay? And then 1 calorie equals 4.184 joules. Don't forget that. 1 calorie equals 4.184 joules. That's important. Write it down. Next. This is the topic, specific heat or specific heat capacity. The way I explain it is a unique capacity, a unique feature of a substance to take in heat and change its temperature. And this is the textbook definition. The specific heat capacity, or simply specific heat, of a substance is the amount of heat it takes to raise the temperature of 1 gram of the substance 1 degree Celsius. The units are joules per gram times degree Celsius, or calorie per gram times degree Celsius. Don't worry about it. I'm going to explain where that comes from, okay? Just don't forget, every substance material is different as far as their specific heat. That's why it's specific, okay? It is specific for every material, and it's also related to mass. This is the equation. I'm going to read using variables. It says C equals Q divided by M times delta T. It reads, the specific heat capacity is equal to heat energy divided by the product of the mass times the change in temperature. What is that triangle delta T? If you remember, that is change. So change in temperature is equal to the final temperature minus initial temperature. And then I have it here, you can see it. This is, let me use this. Delta T is equal to T final minus T initial, okay? Then C, specific heat. Think of it as specific heat capacity, therefore the C. And then M, as always, for mass, in grams. Q, that's the letter for heat energy, which we're going to measure in joules or calories. Delta T, change in temperature in degrees Celsius. We are going to use Kelvin, but we're starting, so degrees Celsius. Now, example number 1. It says, the temperature of a 95.4 gram piece of copper increases from 25 degrees Celsius to 48 degrees Celsius when the copper absorbs 849 joules of heat. What is the specific heat capacity of copper? And with these kind of problems, you always start with the given. So we write given. And that is the information which is being provided by the problem so we can solve it. Okay? And the way I would always suggest you start is look for numbers. With the first number that we see is 95.4. And then we see grams. Grams is related to mass. Thus, we have the mass. Mass equals 95.4 grams. What is the next number that we see? 25 degrees Celsius and then 48 degrees Celsius. What is the temperature? Starting temperature? 25 degrees, because it's going from 25 to 48. So temperature initial, TI, equals 25.0 degrees Celsius. The 0.0 is for significant digits, okay? Then temperature final, we said it was 48.0 degrees Celsius. Then we have 849 joules of heat. Joules, energy, heat energy, so that would be Q. 849 joules. We're looking for specific heat capacity. That would be C equals question mark. Before we start with the equation, this is a step which I recommend you always do. Find delta T. Delta T equals temperature final minus temperature initial. We have both of them, so delta T equals 48.0 degrees Celsius minus 25.0 degrees Celsius, and that is 23. Yes. Okay, now let's write down our equation. So let me show it to you in case you don't remember which one it is. This one over here. So heat capacity is equal to heat divided by the mass times delta T. Okay, let's substitute. C equals Q, that would be 849 joules. So 849 joules divided by these parentheses, so you can see the multiplication. Mass 95.4 grams times delta T 23 degrees Celsius parentheses. So here you go. Let me erase this real quick. That would be 849 divided by, we're going to use parentheses, okay? Parentheses, double parentheses. You'll see why. 95.4, close the parentheses, times parentheses 23, and then close the double parentheses, so you can indicate you're going to divide by the product of these two numbers. Press enter, and we have 0.369. We have 3 significant digits, so I'm going to round to 0.387, which is this number over here. I'm gonna write C over here. C equals 0.387. Oh, let me do this weird 7 so you don't get it confused. And then the units, joules per gram times degrees Celsius. So this is where it comes from. Joules per gram times degrees Celsius. So don't forget, do not miss out on points because of the units. You box it, and that is the specific heat capacity of copper. That's it, guys, for this problem.